So now we will look at the additivity requirement, which says that for two different total claim sizes that we look at, S of t and S prime of t, if we assume that these two are independent, then the total cost for these claims, so the total cost when we add them together, should be the cost of insuring S of t plus the cost of insuring S prime. And we kind of think of, well, this should kind of make sense in a way, right? Because, or else, you know, if the total cost, for example, is higher, then we will always just choose to insure things together instead of splitting them up and stuff like that. So the additivity requirement kind of seems to make intuitive sense as well. Now let's see if the premium calculation principles also satisfy this. So in the net value principle, everything seems to go along pretty fine, right? When I consider the mean value of S of t plus S prime of t. Well, just by additivity of the, or linearity of the expectation, I can split this up, and then I get the mean value of S of t plus the mean value of S prime of t. And this is, well, equal to the price of S of t plus the price of S prime of t. So additivity is satisfied in the first principle. Now let's look at the second principle. Well, basically the only thing that happens in the second principle when we check is the same as up here, except I multiply 1 plus rho, and the 1 plus rho kind of continues on and continues on. So the expected value principle also satisfies additivity. Check if you're not convinced. So let's just continue on to the variance principle and see what happens here. So then we will look at the mean value of S of t plus S prime of t plus alpha multiplied by the variance of S of t plus S prime of t. Now recall that if two stochastic variables are independent, so if I have two stochastic variables that are independent, then their variance, sorry, I've lost my mouse, here it is, then the variance of their sum is equal to the sum of the variances. So that is what we will use here to split up the variance of the sums. So I have the mean of S of t plus alpha multiplied by the variance of S of t plus the mean of S prime of t multiplied plus alpha multiplied by the variance plus alpha multiplied by the variance of S prime of t. And I recognize this part as the price under the variance principle for S of t, and this part as the price under the variance principle for insuring S prime of t. So additivity is also satisfied here. However, additivity is not satisfied in the standard deviation principle. And why is that? Well, that is because if we just consider the term where I have the variance of S of t plus S prime of t inside here, this is not equal to the standard deviation of S of t plus the standard deviation of S prime of t, right? In most cases, these two are not equal. So in that case, I will not be able to have additivity if I price according to the standard deviation principle. So that was additivity. Now let's just finish off with the last theoretical requirement, which is called homogeneity or proportionality. I'll just call it proportionality, which says the price for ensuring some scaled up or scaled down version of the total claim size should be equal to the price of ensuring the total claim size, and then just scaling that price up or down with the same factor. So if the total claim size goes down to a half of what it was, then the price should also go down to half of the original price, and so on. So let's just see if that happens. In the net value principle, I have the mean of S of t. Well, I can take the constant outside, and then I have that ensuring some constant c multiplied by my total claim size. It just costs the same as what it would cost to insure the total claim size, S of t, and then scaling with the c. So proportionality is satisfied here. In the expected value principle, the same thing happens more or less. I just have a 1 plus row on top. So this is pretty simple. I can take the c outside, and I get that proportionality is also satisfied in the expected value case. Now let's take a look at the variance principle. The thing that's the problem with the variance principle is not the first term. The first term is fine, but on the second term we see that if I multiply S of t by c inside the variance, then the second term will be scaled up too much when I try to take out c. So I will get alpha multiplied by c squared multiplied by the variance of S of t, which is a problem because this is not equal to a scaled up version of the premium according to the variance principle, because, you know, for this to hold I would need a c instead of c squared here. So the variance principle does not satisfy proportionality. And now to the last principle. The reason why the variance principle did not satisfy proportionality was because the c inside here gets put outside the variance as a c squared. However, if we take the square root of the variance, then we are home safe again, right? Because then I have, let's see, plus alpha, and then I take the square root of the variance of c multiplied by S of t, and this is equal to c multiplied by the mean of S of t plus alpha. Take the c outside the variance is c squared, outside the square root is c, and then I can take this c outside the parenthesis. So what I have inside the parenthesis is just alpha and the standard deviation of S of t. And this is equal to c multiplied by the price of S of t under the standard deviation principle. And hence proportionality is satisfied in all three cases, and the only case where it's not satisfied is for the variance principle. And what we've actually kind of concluded here is for these 4 different theoretical requirements that we've gone through, at least each of these principles has at least one of the requirements that it doesn't satisfy. So it's only the most boring principle of all, the net value principle, that satisfies all of these requirements. On the other hand, it might lead you to ruin. So that was the conclusion of this exercise. See you next week.